Now, when you are running the coverage, there are two types of coverage which are available. First one are called as static simulations. So the first thing that you will run is a static simulation only. As soon as your site is ready, you can run the coverage. It will give you static simulation files like how much is going to be your RSRP, how much is going to be your best server by which is going to be your best server by RSRP, how much is going to be a downlink loss. So these are some of the information, and that's how a real network export would look like. So these are the areas which are covered with the bad. So the pink color represents the bad coverage and the dark blue color represents the good coverage. So near to the sites, you will see dark blue coverage, and then when you move away, it will become bad or like that. So these are static simulations. And then there are other things called dynamic simulations, or which is also known as Monte Carlo simulations. These are very extensive information. This carries extensive information. It is not just about the coverage and which is the best server. It is about how your network is behaving. That means what is the throughputs, right? What all are the RSRP? What is the quality? What is the maximum achievable throughput? What is the average throughput? What is the peak throughput? What is the application throughput? How many number of downlink carriers which are giving coverage? If this is the best server here, which is the next best server? This one, or this one, right? So these are the information which are present in the dynamic simulation, but the input required for dynamic simulation is the traffic details. That means the type of services that you are going to use, the type of terminals that you are going to define. Different types of clutter parameters will also be required for doing the traffic distribution, and what all bearers are there, all these are required. Along with that, you can also input the interference from the live network, or you can run the interference using an interference wizard from the tool also. And after that, when you run the simulator wizard, it is going to give you a dynamic simulations. Now, let me tell you what is the difference between a static simulation and a dynamic simulation. Dynamic simulations, which are also known as the Monte Carlo simulations, they run on the principle of probability algorithm called Monte Carlo. So in this case, you are not only concerned about how much coverage that you are getting, you are basically concerned about how your network is behaving when there is actual traffic. So we will distribute the base stations throughout the areas, and that one of the distribution is called as one snapshots. So once you run the coverage prediction in this snapshot, after that you are going to run another snapshot, and all these traffics are going to be distributed on different areas using the same Monte Carlo algorithms, right? And they will randomly, scatter in different locations, and that will be considered as your second snapshot. And similarly, how many snapshots you are defining, 50, 100, 500, your overall simulations are going to take that much of time and will give you all these arrays, your throughputs in the uplink direction, throughputs in the downlink directions, interference, coverage balance, all the things that you could think of or the tool is capable to take out will all be defined in the Monte Carlo simulations, right? When you reduce the number of snapshots, let's say if you are running it for 10 snapshots, the coverage accuracy is low. When you increase the number of snapshots, your coverage reliability and accuracy increases. That is about the Monte Carlo simulations. So I'm going to rephrase what all we learned. So you all know now what all are the inputs required in the planning tool. you know the workflow, how a planning tool works, and we also know the basic difference between the Monte Carlo simulations and the static simulation. That's what we have in this chapter. I will see you in the next chapter. Thank you so much.